Hello, welcome back. Today, what we're going to do is we're going to talk about geometric symbols and representations, right? So in geometry, there are a lot of different like little notation-y things that help us determine, what is the thing we're talking about without having to write out like, oh, this is the line, blah, 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 every single time. So that's what we're going to start off with, right? We're talking about a line. And the symbol we use for a line, right, it's named by 2 points usually. All right, so let's say that those 2 points were A and B, and let's make that a little bigger. All right, so let's say that it was 2 points on the line, A and B, and the symbol that we use is just like a little tiny arrow with arrows on both ends right above it. All right, that's all you need to do in order to denote that something is a line. When we're talking about the meaning or the definition of it, right, it is a straight one-dimensional figure, right? A line just goes in one direction. Well, I guess in both directions, but straight one-dimensional figure with no thickness that extends infinitely in both directions. Right? A line does not stop. It keeps on going forever, right? In order to draw a line, right, you might think like, oh yeah, well, that's fine. I'll just draw a line, right? There is a little bit more to it, but that's the gist, right? A line in geometry needs to have arrows on both ends showing that it goes on forever, as we mentioned. It also should have the 2 points that you're naming it by, right? So it was named off of A and B, so it should have one point A and another point called B, right? So those are the things we need in order to make a diagram of a line in geometry, right? As far as a line segment goes, as the name kind of implies, it is a portion of a line with 2 distinct endpoints. Right, so a line segment doesn't go on forever, right? You're just literally taking, as the name implies, a segment of that line, right? The way that we denote that, right? Let's use A and B. Right, so it's going to be A and B, and we're going to draw a line above it, and that's going to be it, right? There are no arrows on the ends because it's saying, all right, it's just this little chunk that goes directly from A and stops at B, right? As far as drawing that, again, it's not going to be too difficult. You're just drawing, again, a line, right? But in this case, it's going to, instead of having arrows on the ends, that's where those endpoints are going to go, right? And I named this one off of A and B. So I'm going to name that one A, and I'm going to name this one B. And that's it, right? That is a line segment, right? So again, differences from the first one are the arrows on the ends and the fact that those points are right smack dab at the ends of those segments, right? A ray, right, is also, again, pretty similar to a line, right? We're going to use A and B for notation again. We're going to draw a line above them, and then what we're going to do is we're going to put an arrow on just one end. And usually it's the end that's, with the second letter, right? That's usually how we denote a ray. A ray is really just a portion of a line with one distinct endpoint and some sort of a direction. Right? So in order to draw that, right, again, I'm going to draw some sort of a line. I need to choose one distinct endpoint, right? So I'm going to put a point on one of the ends, right? And then based on our notation, right, it really matters, right? A was the one that doesn't have the little arrow when I was notating it before. So that means that over here, I'm going to have to make sure that A is the endpoint. The other piece, B, right, is kind of over by an arrow, right? So we're going to put an arrow on one end. And then B is kind of the direction we're heading in. So we put another dot, again, towards the end of that arrow, and we put a B on it, right? So, we talked about a line, which goes on forever in both directions, a line segment, which has 2 distinct endpoints, right? It stops at each one of those, and then a ray, which kind of starts in one place and goes on forever in one direction, right? These other ones are going to kind of build off of some of those concepts that we just talked about. First one of those is an angle, right? So an angle, the symbol we use for this kind of varies depending on who you ask. Some people like to draw it as just like this L with kind of a big slant to it. Sometimes people will go like that, but then also put a little thing through it. I like to draw mine this third way, where it's just like a little less than sign with an angle through it like that. And then what we do is we name it by 3 letters, right? So let's say that we have angle cat, right? And you can do that on all 3. And again, my preferred one is this third one down here. You don't have to use that one if you prefer one of the other two. Right? But what an angle is it's a union, right? It's where these things meet. It's a union of two rays with the same endpoint. Right? So it's kind of like they're both starting in the same place and going out in different directions. Right? So I'm going to draw one line, and then I'm going to draw a second line that's attached to part of that. Right? To turn these into rays, right, this is the end point that they share, right? This is kind of where they both start. The direction they go in is just kind of leading out from there. Okay. When we're naming an angle, especially the points in an angle, we do need to, put those other dots on there. And the ordering does matter, right? If I have angle CAT, the middle letter needs to be that point where it kind of pivots, where it turns. Right? The other two can kind of go wherever, right? I could name this one C and this one T, or I could go in reverse, right? I could name this one C. Is that what I just did? I'm having trouble remembering, right? We could also name them in reverse. Yeah, no, that's what I just did. I can name this one C and this one T up top, right? But the important part is that A has to be in the middle because it was in the middle when we were doing the notation over on the left there. So just something a little tricky about those to keep track of. When we've got perpendicular lines, we use a kind of a weird looking symbol. You take a capital T and you flip it upside down. Oops, let's make that a little bit nicer. Right, so that is the symbol we use to show that two lines are perpendicular. Right, and when we're talking about perpendicular lines, they are lines that intersect at a right angle. Right? If you forgot what a right angle is, it is 90 degrees. Right? So what we need to do in order to draw perpendicular lines is, I'm just going to draw one line. And again, it's an entire line, so I'm going to put the arrows on the ends and everything. And then I want to draw one that seems like it intersects it at a 90-degree angle. All right, so I'm going to do my best. That doesn't look so bad, all right? When we're drawing these by hand, it's never going to be absolutely perfect, right? So don't spend like 4 hours trying to get a perfect perpendicular line, right? What we're going to do is we're going to add in one more symbol to this that shows us that it is definitely 90 degrees, that it is a right angle. So you may have seen this before. We're just going to draw a little like boxy square corner in there, right? That is telling us that that is a 90-degree angle there, right? So that shows us that those lines are perpendicular, and that's all we really got to do for that one, right? So, they weren't necessarily perpendicular until I put that in there because, I can only be so precise, right? Maybe my angle that I drew originally was 89.8 degrees or something like that, right? The only way to absolutely be certain is to put that symbol in the middle there. All right. On to the back side of this, right, we're going to talk about parallel lines. So the symbol for parallel lines is just like a quick little double L, right? It's showing two lines that are not crossing each other. And that's really what our definition is, right? Parallel lines are coplanar lines that will never intersect, right? They are never going to cross each other, right? So for our diagram, what I want you to do is try and draw two straight lines as best you can going in the same direction, right? That's pretty okay. Put those arrows on the ends as we normally do. And then what I need to do, again, just like with the perpendicular lines, they weren't perpendicular until I put that little right angle marking in there. For parallel lines, they're not parallel until I add, again, a little bit of an extra marking. So the marking can look a couple different ways. I'm actually going to zoom in just so we can show them off. One way that you might see is if you have, just extra little arrows somewhere in the middle, right? The fact that they each have two is telling me, all right, they're traveling in the exact same direction. They are never going to cross each other, right? So that's one way that you might see those. Another way you might see them is with like little filled in triangles just like that, right? That can also mean that they are perpendicular, right? Either one is fine. I find that these ones are a little bit easier to just kind of pop in there. You don't need to fill in a triangle or anything like that. And they mean the same thing, right? So these are parallel lines, only after I put that symbol in there. Then we're going to talk about what the word congruent means. And congruent is something that's going to come up quite a bit this trimester and also when you get into Geometry B. So the symbol for congruent, right? You take an equal sign and then you put like a little squiggle over the top, right? So, the equal sign is kind of giving me the idea that, things are going to be pretty similar, right? They might almost even be equal to each other. But the little squiggle's telling me it's a little bit more than that. So when we have two things that are congruent, that means that they are geometrically the same size and shape, right? So basically it's saying like, all right, I have two triangles, right? If I have two triangles that are the exact same size, then they're congruent, right? They are the same size and the same shape. You cannot have a triangle that is congruent to a rectangle, right? They're not the same shape, right? That doesn't work out, right? So as far as congruent lines go, right, you would actually probably say congruent line segments. I might make that correction on there. So if I had congruent line segments, right, that just means that I have, one line segment over here. Say that it goes from A to B. Somewhere else in this little box, I'm going to draw another little line segment that hopefully is around the same length, kind of. Oops. We'll zoom back in there. And I'm going to call that one CD. Right? So to show that they are exactly the same size for line segments, what we do is we put a little tick mark in the middle of them. Right? Otherwise, I don't know that they are exactly the same length, right? One might be 17.2 centimeters and the other one might be 17.18 centimeters or something like that. But once I put that little line in there, I'm saying these are supposed to be the exact same size as each other. If you have more than one pair of congruent line segments, you can also put more lines in them, right? You can match them up. If they both have two, they're equal to each other, right? You can also do something similar for congruent angles, right? So you may notice there's no definitions or anything over here, right? So kind of leave that out, right? When I'm talking about congruent angles, right, I'm just going to draw two angles, right? Something like that. Say that we have that angle there. We gotta, again, name it with some letters. Let's do angle CAT like we had before. And then let's say that we have this angle over here. Oops. Shouldn't have put those dots on the very ends. Let me back up a little bit. Arrows on the ends, dots a little bit further back. Say that this is angle DOG, right? So the way that we show that two angles are the exact same measure is with little arc things that we put on the inside of them, right? Those little blue markings there are telling me that those angles are the exact same size. And again, just like with the line segments, if you put two in there, then again, all the ones with two little arcs in there mean that those match up, right? Last little thing with congruent is that we want to kind of show the notation for how I would talk about these things, right? We talked about the symbol, right? It's that squiggle over the equal sign. But if I have congruent line segments, right, what I would do is I would name them, I have segment AB and segment CD. What I would do is I would just put that little congruent symbol in between them, right? AB is congruent to CD. Same thing with angles. If I had angle CAT and angle DOG, right? In order to show that they are congruent, I would just put that little symbol in the middle of them, right? And that's all there is to those. All right, we got a couple more definitions, and we'll take a look at a few diagrams before finishing up. So we've got a circle, right? You might think oh, I know how to draw a circle, right? Which is good, right? That's basically what our notation is, right? So let's say for our circle, I need to draw, again, this tiny little circle. Oops. Let me try that one more time. Circle, you want to put a little dot in the middle, and then you're going to label it with a point. All right, so we're going to call this Circle A. And actually, you know what? Just like the convenience store, let's call it Circle K. Why not? Hopefully they don't copyright claim my video. So a circle is a set of points that are all equidistant, right? Equally distant. They're all the same distance away from a common center point on a plane, right? So you might have not have thought about circles in this way before, right? But circles are a bunch of points that are all the same exact distance from a center point, right? So I'm going to draw my best circle in there. Oops. Let's see if I can do a little better. All right, when we're doing these freehand, it's never going to be perfect. Wow, look at me go. That's so good. Oops, and then I erased it by accident. So what we need to do is somewhere around where the middle of our circle is, I'm going to put a little dot in there. And then I called it circle K. I'm going to have to label that point K. Right? And that's it for a circle, right? Mine auto-filled in when it made the nice shape. Yours does not have to be shaded in like that, right? So don't worry about that piece. All right. Two last little bits. We got midpoint and we got distance, right? So we're talking about midpoint. There is no notation for it. And actually, it's going to be the same thing for distance, right? We don't really have... Oh, actually, I'm incorrect. For midpoint, we don't have a symbol. For distance, we'll talk about it in a second. For midpoint, it's really just a point that bisects a segment into two equal pieces. Right? If you're familiar with the word bisects already, you might already know that that's what it means. It splits it into two equal halves, right? The way that we would show that in a diagram, right, is let's take one big line segment. It's going to go from A to B, right? And then somewhere in the middle there, I'm going to try and find a midpoint, right? Wherever it looks like it's about halfway, we're going to call that C, right? So just like when we were talking about congruent line segments, we need a way to show that those two halves are exactly the same size. So what we're going to do is we're going to put those little tick marks in there, showing that one piece is congruent, right, is the same size as the other piece. Right? So that's it for midpoint, right? It's just something that's in between two other points, right smack dab in the middle. For distance, right, you know how I mentioned for a second there was no notation? It's because I forget sometimes. This one's hard to remember. So distance, let's say that we've got AB, and the distance from A to B is equal to 6 units, right? I don't know what the units are, but it's 6, right? You might notice, you know, when I wrote AB, I'm not putting a line over it. I'm not putting a line segment thing over it. I'm not putting a ray over it, nothing, right? It's just saying like, all right, the distance to go from A to B, right? And that's all it's doing, right? So distance is the measure of length between 2 points, right? So it's just, again, how far it is. In order to show that in a diagram, right, we're first going to draw ourselves out some sort of line segment, put A on one side and B on the other. And then to show distance, right, there's a couple different things we can do. One of which is we can draw this little fancy curly brace and label it with 6 and say like, all right, that from there to there, that's 6. Right. One way that you'll probably see, especially if you're into like any sort of like carpentry, or if you want to become an engineer, do something with like that with construction, you'll have these two little markings that kind of go up from there, and then you just kind of extend them like really long T's, and then you put the 6 in the middle, and it's saying like, all right, it's 6 from one end of this piece to the other end. Right. This is the way that I like to do it. You know, if you like the little squiggly curly brace instead, also fine. Right. So that is all our definitions. Oh my goodness. Right. We're going to take a quick look at some diagrams just to kind of practice with these a little bit, and then we'll be done. Right. So on this one, we've got ray AP is perpendicular to line segment WQ. So what we're first going to do is we're going to write it symbolically. So we're going to take it one piece at a time. We've got ray AP. So AP, and then to make it a ray, I'm going to put a little arrow with one direction on it. The next piece we're saying is that it's perpendicular, right? When we're perpendicular, we do that upside down T, and that's all we need. And then when we've got line segment WQ, we're going to have W and Q. And then if it's a line segment, it doesn't go, it stops at either end, right? It doesn't go on forever in either direction. So we just put a little line over it, and that's it. So symbolically, we've just converted that into like geometry symbols, which is pretty neat. As far as a diagram goes, right, I'm going to draw ray AP, and something like this. It's got an end point and a direction. And then I want it to be perpendicular to line segment WQ. Right, so I'm going to try and draw a line segment that is as perpendicular as I can kind of come up with. because it's a line segment, it's got those endpoints on it, one of which is W and the other is Q. And then I need to show that they are perpendicular, right? And again, the way that I do that is I put that little like square angle marking in there somewhere where they cross. That's telling me that it's a right angle, which is what makes them perpendicular, right? Hopefully that's not too bad, right? It's just like using what we were just talking about, right? If you need to flip back and forth as we're going through these, not a bad idea. So if I had segment JC that is congruent to segment RF, right? First, let's go and get it symbolically, right? So segment JC. So we got J and we've got C. A segment means that it's going to just kind of stop like that. If we're congruent, that's the equal sign with the squiggle on top of it. And then segment RF is really not that dissimilar from what we just started off with, right? So symbolically, that's all we need. As far as a diagram goes, right, again, we need a segment called JC. All right, so it's going to have points at either ends, one called J and one called C. We also then need another segment called RF. And then we somehow need to show that they are congruent, right? So again, this is something that we're going to need to use a lot, right? When we're talking about congruent pieces, we're going to be talking about them a lot. So in order to show that they are congruent, I'm just going to put the little tick marks right through them. Since I put 2 on the first one, it needs to match up with the other one, so I put 2 on there as well. You could also put 1, you could also put 5, you could put 8. You know, I wouldn't suggest putting 8 because it gets a little tricky, but there we go. All right. What I might like you to do is try pausing here, give this a go. See if you can do line KB is parallel to line segment AG, right? If you need to flip back and forth, that's okay. If you even just get the symbolic part, also fine. But pause here, try it out. Hopefully you gave that a go. I'm going to kind of run through it. Line KB. So we've got K and we've got B, and to show it's a line, we'll put that line with the arrows above it. If we're showing that it's parallel, that's where we do the little double L thing like that. And then if we're talking about it being parallel to line segment AG, it's A, G, and then that segment piece over it, right? As far as a diagram goes, right, we need a line called KB. So remember, a line specifically has arrows on both ends. So we're going to put those points somewhere else in there. We need a line segment AG, and preferably something that looks sort of parallel, right? Because that's going to be our next step, is to show that these are parallel to each other. So again, there's a couple. There's like two different ways that I showed you. There are some more that I'm not super familiar with, but I'm sure they're out there, right? The way that I would suggest it is just put these little arrows that show like, all right, these are going in the exact same direction. They will never cross. Therefore, they're parallel to each other. Right. Again, if you haven't tried one, pause here. Try this one out. Try and see if you can get angle cat to be congruent to angle dog, right? Spoiler alert, it's kind of what we did earlier, right? Let's kind of run through this real quick. Angle CAT would look like this symbolically. If we're congruent, just like the last one, we do the squiggly equal sign. And then angle DOG, just like that. All right, so cat is congruent to dog as far as a diagram goes. All right, something like that. We've got an angle there. And again, remember that when we're labeling this diagram, the fact that A is in the middle of that angle means that A is the part where it kind of like pivots, where it turns. The other two can go in whichever order you want. So you got angle CAT. And then we're also going to have angle DOG. And again, it's just a matter of making sure that that middle letter is in the middle of your angle. In order to show that these are congruent, right, hopefully you remember that what we need to do is we put these little arc markings on the inside of the angle, right? And again, it's just like the ones with segments. If I put 2 in the first one, it also needs to match up, and I need to have 2 in the second. I could also just put 1, I could put 3, I could put many more, right? But, 1, 2, or 3 is also fine. Right? So I will say, if you tried some of these last ones on your own and you got them right, awesome job, right? Hopefully it doesn't seem as bad as it might have when you first looked at this page and you're like, oh my goodness, how am I going to do this? Right? So again, try pausing here if you're feeling comfortable. This one's a little bit on the tricky side. We've got line segment CF. So because it's a segment, I'm going to notate it just like that. Has a distance of 8 units, right? And already I'm noticing like, oh, shoot, I messed up. If we're talking about distance, right? Remember I was talking about this is the hard one to remember, right? When you're talking about distance, you don't have to put that little marking above it, right? All I'm going to say is that it's equal to however many things it tells me about, right? When you're talking about something that's just as generic as units, you don't need to put units on there. It's just saying like it's 8 somethings, right? But that's how we would symbolically represent that, right? So again, you just saw me make a mistake on it already. Remember that distance doesn't have the little markings over it. If you're not talking about distance, it should have some sort of marking above C and F, right? So when I'm writing this, or when I'm drawing this out, I need C over to F. It is a line segment, so I do need to make sure it has those endpoints. If we're talking about distance, right, I'm going from one end to the other. And then somewhere in the middle there is where I put my measurement, right? It's 8 units. What are they? I don't know. Maybe they're meters. Maybe they're inches. Who knows? And that's it for that one. Ooh, circle W. Easy to write, hard to draw, right? So we've got circle W. Right, remember that it's just a circle with a dot in the middle to represent that center point, which is called W. When I'm drawing it in my diagram, right, we're going to draw, wow, look at that perfect circle that I drew all on my own with no help. We're going to put that dot right in the middle, and we're going to call it W. And that's it. That is circle W. Done. Ooh, midpoint. Be a little bit tricky. There's a few different pieces to remember, right? So we've got the midpoint of segment RT is point H, right? So as far as notation goes, you might notice that there was no thing asking for it symbolically, right? It's because we don't have one for midpoint. When we're drawing this out, right, we need the segment called RT. Right, so R is one endpoint, T is the other. And their midpoint is point H, somewhere where the center appears to be. To show us that that is the midpoint, what I need to do is I need to put those little tick marks on the inside of it, right? Showing that that 1/2 on the left is equal to, like, the same exact size as the piece on the right. Right? So, again, hopefully this isn't so super duper bad. What I'd like you to do is try one on your own, right? Write the description in words. It doesn't have to be super lengthy. Try to come up with something better than just like circle A, haha. Try something a little bit more complex. See if you can get it symbolically, and then see if you can get the diagram for it. And then next time I see you in person, we'll take a look at them, and we'll see how we did. As is, that's it for right now. So I'm going to say peace out and see you later. Bye.